Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about NASA Space Reactor 1. Freedom. Basically, America wants to give freedom to Mars. So let's dive deep into it. So the announcement was done by this gentleman and it was a very weird stream, so much empty space. So this would be the first time humanity as a whole will put fission nuclear reactor that is outside of the planet. Meaning, have we put reactors in space? Yes. Have we put any reactor that is outside of Earth? Nope. As in like Earth's sphere, so to say. So this will be the first time. And the main reason for that is NASA non-stop has been working on nuclear technology for decades. Basically, NASA started, nuclear pipeline started, and it never turned off. It consumed billions of dollars, but there is no utilization. So this would be the first time that's actually doing something, actually, moving ass. So this will be the first time that happens. And this is not what you classify as a main mission or even a flagship mission. All it is pathfinder, meaning prove the concept that it works. Nothing more than that. Like just validate the idea that all the billions we spent actually gave something. So low risk and high reward kind of scenario. Pathfinder. That's why it's not trying to do something extreme, and this is another reason why they do not want to directly test it on Moon, because in Moon you also have to figure out how to land. Here it does not have to figure out how to land. It just goes into space, turns on, stays in space. On Moon reactor you have to send it to space, successfully land it into Mars, and then turn it on, and then hope everything is fine. So this is one less risky step. So this is first Pathfinder. And if you have the ability to have nuclear fission, you get two vectors. Unless you have super duper high powerful reactor, you have two options. Option number one is you can cut the travel time, meaning if let's just say you are sending Perseverance 2, you can send it instead of like a normal rocket will take let's say 8 to 9 months. This puppy can do that in 3 months. So that's one option. Second option is send more, but now your time will remain the same, but mass to Mars will go up exponentially. So this is what they are aiming for. They are not aiming for something faster, they are aiming for something massive. And if you watch the movie Martian, that ship was huge. It had iron engines. Why the heck it was so slow? It was not slow, it was massive. Basically, science can balance it out. Unless you have like, Tony Stark arc reactor, you have to make a trade-off, whether you focus on carrying more ton or you focus on going faster. So this is staying on the same Hohmann transfer method. Only difference would be instead of carrying one tiny payload, it's carrying a lot of payload. And rocket is not throwing this to Mars. Rocket is not even throwing it to the Moon. High energetic elliptical orbit, something like that. And then a nuclear engine is like, I got this, fam. That's the main advantage here. So, and now aim here is not to go quicker, it's just to send lot of mass, meaning the whole system is much heavier. And right now I don't even think there is any practical rocket that can carry it. And no, Starship is not a practical rocket if you have to refuel that puppy 20-30 times in orbit. So, and even that's like stretching it. This is like, I can do this all day. So that's the whole point. The announcement was done in 26 March 2026 ignition event, and it's gonna do in the next transfer event, which apparently I wrote wrong. It's supposed to be in 2028 Hohmann transfer method. So this is the whole point. Now, have we used fission reactor? Yes, we have used fission reactor. The first reactor was Soviet BES reactor 1970, and it had thermoelectric converter exactly like RTG. Only difference was RTG runs on passive radioactive decay. This relied on fission reactor, meaning they had some control vector, and they can make sure the flatter energy curve happens because it will not cool down so much. So that was Mark 1 technology. They launched it, if I'm not mistaken, upwards of 30 times. They went YOLO on it. And after that, Soviet learned and expanded. They created Topaz reactor, this puppy. The Topaz reactor was a final technology. Basically, the reactor technology was mature at that point. But how do you convert heat into electricity? That was not. So they invented thermionic converters. The idea is instead of basically how photons allows electron to jump the band gap, and that's how your solar panels work. This would be something similar. Instead of photon is thermal electron that is forcing it, that like you have the bridge and you have forcing system. And the whole point was this was 1 to 2% more efficient than thermoelectric converter. Again, only one of them flew. So the idea was they were getting like the core heater element was 115 kilowatts and they were getting 5 kilowatt of electrical energy. Nowadays, we'll laugh at that because we have solar panel, but be mindful, this is a early 70s. So it makes sense for that time. And again, the efficiency, that's the biggest thing. We have put reactors multiple times. It's just that it was never efficient enough to justify it. And America got such a bad deal from it. They tried a Snap 10-1 reactor. And again, you can watch photos. They were building multiple of this at the same time. They were so confident about it. They launched it in 1965. Yeah, it had electrical fault in 43 days. Not a nuclear failure, electrical failure. Oh, by the way, it's still flying in the space. So if there is a tomorrow Castle syndrome, there is a very good chance we have too many random reactors falling into Earth, which are radioactive, idiotically radioactive. So that's the whole thing. So over time, most countries realized that it was stupid and RTGs can do everything that you want to do. So let's just... And Cosmos 954 actually did the worst case scenario. In 1978, it pooped and it basically pooped the whole Canada. Like Canada had to spend bonkers amount of money to scavenge where the heck it is. And like the whole pieces fell through and it was contaminating the much larger area, much larger, like your orbital debris, radioactive, hyper radioactive orbital debris. So this is basically, let's just put it that way. This gave whole world enough of a bitch slap. They're like, let's just not do it. RTG, we good. Now you're like, okay, wouldn't RTG have this risk? Yes, but no. While RTG has the risk of crashing and falling and all that, but it is carrying a pacified state, so to say. It's not an active fissioning reactor. There is no neutron emission. It's done. So it's much tamer compared to an active working reactor. Active working reactor is you do not want it. Let's just put it that way. So SR-1 is that technology with modern safety. So power and propulsion element. This puppy was built for Lunar Gateway. Do not ask who came up with Lunar Gateway. It was a stupid idea. So they had a problem. Earth's gravity is far smoother because Earth is huge. Gravity well is smooth. The moment you are talking about something small like a moon, the gravity is not smooth. So it has like very undulation, so to say. Problem is, if you put anything in orbit and you're trying to maintain it, yeah, it's not going to maintain for long. Even if you're like, okay, we're going to do halo elliptical orbit, whatever the heck you want to do, it will not remain stable. So they require a lot of course correction. How the heck you will do that? ISS does boosting and all that by utilizing rockets that are from the cargo vessel. But it is taking so much energy to go to the lunar docking point where they won't have enough propellant to do additional pushing. So what to do? It will have its own element. This is the element. This element, how the heck you going to refuel it? Well, you won't. You just have enough xenon on site that with Hall effect thruster, this is like I can maintain it. Hall effect thruster can do very serious thrust if you run it long enough. So they're like, okay, we may not have that long enough. So they increase the power. So this puppy was planned for as high as 60 kilowatts of ion thruster going YOLO on xenon. Once in a while, the target was, I think, 10 years. After 10 years, they have to refill the xenon. So they will have one dedicated mission just to refill the xenon. So it was the design parameters or day one. So this would, if it have flown, it would have been the most powerful ion thruster in real world. So now they are toning it down. Apparently it's a 48 kilowatt of Hall effect thrusters with xenon as a fuel, and they have solar power. Now, why they have solar power? The original design was completely designed for solar power. Like, if I'm not mistaken, 60 to 70 kilowatts of solar power. So they still have solar power, but I'm pretty sure they shrunk the size of the array, maybe 20 kilowatt or something. So it will act as a backup and it will act as an auxiliary system, because you do not want to use nuclear reactor do not like to have variable power output, so solar will take care of that. And not to mention, after launch, reactor won't be turned on. Reactor will be only turned on once either it's outside of the Earth's influence or on the way to the Mars. So at that time, solar can give you enough of a push. The reactor on paper, they are planning for 20 kilowatt E electrical output. So solar panel can easily provide that. And again, you do not want to count only on batteries. It's like launch it, hope batteries hold, everything is fine, and then we turn on the reactor, then it turns on. So having a solar gives them enough of a buffer time. Like, what can you do before you turn it on? Because before turn on, it's not releasing neutron. After turn on, it has neutron. And not to mention, nuclear reactors do not have an off switch. All you can do is control how much hotter it is. So once you turn it off, quote unquote, like, stop the fission, you still have daughter products. Lot of them, and it's still hot and bonkersly hot, like so hot that if you do not cool it actively, it will go kaboom. Ask Fukushima. So fundamentally, you do not want to turn it on the ground. You want to make sure that they make sure they're as cool as possible. But once they turn it on, they can't do anything after that. So they'll make sure it's only turned on when everything is green, everything is go. They will only want to do that. And this will have radio communication and IR laser communication backhaul. So they are putting the backhaul communication because again, humanity is finally learning that while radio wave does give you the omnidirectionality, meaning look at Earth and signal will reach Earth, laser will require no point at Earth. So it's more difficult, but it can be done. And the beam will diverge. So you have to make sure you are aiming inside Earth. Instead of aiming at Earth, you have to aim inside Earth. But it is doable. And it will have massive bandwidth upgrades, meaning going from kilobits per second to megabytes per second. So massive, massive update. So that backhaul would be tested, if I'm not mistaken, first time for that long range. We have tested it. Orion also has that. That is going around the moon right now. That also has that backhaul. Then that backhaul would be the main backhaul for broadband to moon. So that will be sorted, but this I'm pretty sure will sort it for Mars distance. So that's the whole point, and it will be launched into high Earth orbit. Now, there are other things you have to understand. Nobody knows how this is supposed to be made. This part exists, cool, but here's the deal. This is huge. This was designed as a one main heavy puppy element. You're supposed to launch this on its own. Maybe add something to it, but this was like single ready. And they are saying that we're going to put all this thing in one launch. As in, this whole thing is one launch. So they are this module is ready. This module has to be compact enough and put on top of this. Which payload fairing is big enough for that? I'm genuinely curious. So this actually, okay, makes sense, it will fold. And again, you can see the telescopic design. So, okay, reactor will be here, this wall will be folded, but still would be this size. It's still huge. So I'm not sure which rocket they can do that. And again, not to mention, they have not shown where they have the capsule, the actual payload that they will drop into Mars. So this almost looks like 5-10 minutes of engineering time went into this. Rough idea is there. That's cool, awesome. But it almost like, okay, let's just 1 week, maybe that's how much time they put into this. But it's not a ready design. So rocket is not sorted. Are you gonna launch a reactor separately, or how compact can reactor be? Will everything fit inside it? I doubt it, because it has a high pressure xenon tank. So where do you have spare room for that? Radiator, I can buy that. You can fold radiator, cool, awesome. But the telescopic structure and the heavy reactor, those things are not that easy to compactify, especially the reactor part. So it's a bit uncooked, I would say. This is a rough idea, but I think it needs more cooking. And this is directly from the PPT that NASA has shared. It's available, by the way. So if this does not have it, I do not know what else will have it. So titanium heat rejection system. Okay, what is the temperature of it? So what about the unknowns in this? Well, here's the fission reactor is a mature technology. Can humanity or can NASA start today and be like, okay, we're going to drop a reactor into orbit or on Mars? They can do that? Absolutely. A fission working reactor, that's done. And not to mention, they never turned off the R&D. R&D was always ongoing. For example, this was the most, on-off research, which is NASA kilowatt reactor. So this puppy is supposed to have power rating from 1 kilowatt to 10 kilowatt. And it has the reactor, that red part, that's the reactor. And the part that he's showing, that's the Stirling engine, and the pipes are sodium heat pipes. So that will carry the main energy, so to say. So that research was always ongoing, but it was never fully on, never fully off. So that's what Jared is talking about. Like, we were never shutting off nuclear, but we burnt billions of dollars into it. So not 1 billion, billions. So might as well get something out of it. So I can trust the reactor part. Like, can we make the reactor that is ready to go, shut up, take money, go? Yes. Ion propulsion, yeah, that's a mature technology, known technology. That wise was designed to be used in Lunar Gateway. So that also would be space-worthy, sorted, done, go home. Yeah, thermal to electric conversion. How? Well, we do have a lot of things. First is thermoelectric conversion. That only goes to 1 to 3.5% efficiency. You have to overheat the reactor a lot to do that. That's why this design had Stirling engines. Another is thermionic converter. I have never seen America research into it. Maybe some military projects have researched into it, but I've not seen it. That can push the efficiency to 5%. Okay. But they are saying, what they are saying, claiming, they're going to have an energy conversion system. Basically, this power plant. So At that point in time, it's like we do not have data for Stirling engine, let alone a turbine. And yes, they are planning for a turbine. So turbine, the working fluid is carbon dioxide, not supercritical, but carbon dioxide. And I'm like, yeah, making and validating all of that puppy in 2 years, yeah, that's not happening unless it was already, because this is where I got the data. It was a NASA project. So maybe he knows that there was a project in the back end that they worked, but they never finished it. But I'm like, how can you finish it in 2 years? So because the whole thing is that you have carbon dioxide, cool, awesome, GG. You do not have to worry about it freezing over. But you have to have this system and then seal the whole system into another hermetic seal chamber. So all the leakage that will happen from the bearing surfaces and where you have seal, it will leak, but the second containment will contain it. It will not allow you to lose it. Or you can even have a small pump that is running from that second encapsulation and forcing it back into the working fluid, because otherwise slowly over time you lose all the working fluid. So, and again, you can see this philosophy of hermetically sealing a system in your air conditioner. The worst air conditioner is your car's air conditioner. It has a compressor, but because the motor is not electrical, it's driven by the pulley rod is outside. So they have a seal is going like this, and that seal, if they make it too tight, it will take too much horsepower. If they make it loose, gases leaks out. So that's why cars AC, basically go to any service center, they're like, yeah, we have to refill this system. Do not take your personal experience. Too many people are bad at math. Go to service center. Almost all service center will know how to deal with basically gas leaks. It does not last very long time. Electric vehicle does it because again, it's an electrical motor. So wires only go through it, which is completely encapsulated. Your AC, your refrigerator, those are encapsulated puppies. So this whole thing has to be encapsulated. Yeah, I can buy the reactor. I can buy the lunar gateway module. It's already built, but I can't buy this to be ready in 2 years, unless it's already built for some military project or something, like how Hubble was just a spy satellite. They rotated the spy satellite. That's it. So maybe that's the unknown part. I'm way too shocked how confident he was, like in 2 years. I'm like, yeah, this is not happening in 2 years. Everything else I can buy. Again, you can just buy this, like it's ready, take it and go. This, take it and go. It's just like this. Yeah, no. Now, what is the payload? The skyfall, and that's the difference. This is sending such a big stuff to Mars, and this skyfall, as in like the whole Mars re-entry capsule is there, and it's gonna yeet the capsule into the system. So, and the capsule is daring. To be fair, last two rovers were also daring. They will deploy the heat shield and then drop this hangar. Hangar will let the helicopters fly while it is falling. It's mid-air, one launch, go. There is no second take. Now we did something similar, and I think this is maybe a bit simpler than rocket crane that figured out. It's like, okay, crane is rocket crane, and crane goes, crane allows the rover to land, disconnects it and goes, yeets and goes kaboom. So compared to that, I think this would be far, easier. And they're gonna have 3 helicopters. Now they had original concept of Skysail, which had 6 helicopters. So I think to make sure the time frame shrinks, they are using only 3. The primary payload of those helicopters is ground penetrating radar. This helicopter, the actual Curiosity, Perseverance helicopter, only had cameras, so to say. It was a proof of concept of the rotor design. This is an actual payload mission. So they're gonna do massive sky surveillance. Now, the whole point after the deployment is run as far as possible, because you do not know where this puppy will land. Run as far as possible in a mathematical grid and then land and just chill. Wait for sun to charge you, wait for night, or maybe launch another day, just chill. Once you have everything, then start to scan everything. And if it lasts long enough, let's just say something like this, where it lasts for a year or years, it will give you so much resolution, so much data, that it will bitch slap all the satellites combined plus all the rovers combined. Because you have to understand, like once you're close to something, the data you get even on a poo-poo quality hardware is exponentially better than being orbital distance apart. So fundamentally, the quality of detail would be so high. But what about the rovers? Rovers have a lot of instrument, but they are slow. They're like, bro, you can walk farther than that. It's slow. So this will bypass that slow aspect. And because it does not, if I'm not mistaken, they're supposed to communicate directly to satellites that are in Mars. And then Mars, those relay satellites supposed to dump data communication back to Earth. So they do not have to worry about us, like always stay in the range of the rover. They can fly much faster, much further without too much hassle. As long as they can do safe landing, they're good. They got this. And again, the only reason this fell, it landed at an awkward angle and it had hit the tip of the rotor, so to say. And this time I can pretty sure they're gonna have a much better algorithm and it will never fly on top of a unfeatured terrain. If it detects unfeatured terrain, it's like, nope, let me go on top of rocks, far safer. Because again, that's how it got confused. It did not knew where it was. The calculation was like starting to run out. It's basically a mouse sensor they had on it. So, and this time I'm pretty sure they would have like, okay, we could have done this. So a lot of data, and this project Skyfall was already in advanced design review. So can they pull this off in 2 to 3 years? Maybe. So only unknown part is how the heck you're converting the heat into electricity. Everything else I can buy. But he said, are you gonna use turbine? I'm like, Stirling engine I can buy because you were building this. That's what I've originally thought, that it's a Stirling engine because it's already built. It's called NASA kilowatt reactor. It's ready to go. Why are you going to turbines? Why? And again, maybe they already have something exactly like that ready to go. Maybe, but let's see. So this was my presentation on NASA's freedom to Mars. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.